Well, Monday is here again. I'm going to have a little bit of a random commentary on a few items here, and also a 10-question test, complete with an answer key at the end. I hope you get a lot out of those. I enjoy putting them together. So this right here, anybody that has ever used a VAT-40 charging system, battery tester, knows just how wonderful this box was. That carbon pile knob up there. The coolest thing about this is you could not fool this thing, or at least I never was able to fool it. And I used one at the dealership for years, and there was also one at the college when I first went to teach there. You could not fool that thing. It would always tell you when the stator was bad on that bottom gauge whenever you went into that mode. It was just absolutely, if it said it had a bad stator, you could take it to the bank. These newer testers, whenever you're looking at those, and this was one I bought after the VAT-40 died. The VAT-40s over a period of time, as good as they were, would die, and then you couldn't get them fixed anywhere. And so this was the snap-on unit that I bought at the college, and it had a carbon pile knob, and it was manual, and it basically had some LEDs that would tell you if the stator was bad and all that kind of thing. The problem with that is I couldn't always trust the stator light. When the VAT-40 died at the dealership that I was working at, we needed another unit for that, and we bought a $1,700 unit from the Mac Toolman, which was a pretty good unit. But if you had a bad battery, that little red light that said stator would come on and tell you the stator was bad in the alternator when it wasn't. And so I always had to follow that up. If it told me the stator was bad, you know, of course, testing the battery is always in order anyway. The starting point on any electrical problem is to make sure you got a good strong battery and good battery connections right there at the battery. But this one was a little more reliable than the one we bought off the Mac tool truck when I was at the dealership. But the long and the short of it, I would take a scope and put it on the alternator and read the ripple pattern, because I could typically look at the ripple pattern. If this told me I had a bad stator and the battery and the connections were good, you know, and I followed up with a scope, I would have two pieces of data that I could piece together. Also, another piece of data, if you've got an alternator that's doing a lot of ugly whining, then you can say, well, that may be a bearing or whatever. But more often, when you hear an alternator making a whining noise, that especially if it goes whenever you rev it up, that's typically going to be caused by those magnetic lines of flux in there. Where the stator itself could be the winding, the stator can be shorted, or you can have diode issues. But like a ceiling fan, you know how a ceiling fan, some of them will go when they're running. That's vaguely the same kind of magnetic resonance that's causing the vibration to set up in there. Well, when I started the new automotive program over at this local, there was a dual enrollment program that started at a school down the road a ways. And part of what I was doing as an instructor at the college where I was working was they wanted me to go and launch that automotive program over there. And I wanted a good tester that had a carbon pile on it, and I found one that was very, very similar to this one. Now this one here is about $2,000. You can look it up online. I'm not going to put a link to it or anything. The one that I found that I bought over there for that thing looked almost just exactly like that. Didn't come with a stand or anything, so you'd have to have a table or a stand, or your own stand to put it on. But that one actually had a carbon pile tester, and it was pretty reliable as far as the diode part of it. But I liked to be able to turn that carbon pile knob, put a load on the battery, watch the alternator amperage go up, so you can basically, when you reduce the voltage by turning the carbon pile knob, that's when the voltage regulator kicks in and starts raising the amperage. And that's really a good test. You know, just checking with a voltmeter or something like that to see if your charging system's working right is not really 100% reliable all the time. But anytime you're doing any kind of charging system testing, you always got to start with the foundation has got to be fixed first. So work on the battery and the connections, or check those. If you're going to check the battery, the best way to check the battery is to use one of those testers like Midtronics makes, or any of these other manufacturers, where it tells you how many cold cranking amps is in the battery. I got this BT608 Autel thing I love to use for that. It works really good for it too. There's a lot of tools out there. There's a Midtronics that's got a $1,700 kit that does all kinds of stuff. It guides you through some diagnostic, prints out a little tape and all that. But that's pretty much the long and the short of that. Anytime you're working on any kind of electrical problem, start with making sure you got a good battery. So now they say if you go to half the cold cranking amps for 15 seconds, it ought not to go below 9.6 volts. 9.6 volts. But what I typically was teaching some of my students was that, if let's say you're working on a car that's, in the mid 2000s or whatever, and you want to see if that battery is sufficient to start that car, if you can disable the fuel system or the ignition system or whatever, and spin the engine for 15 seconds while watching the voltage with a voltmeter, if it doesn't go below 9.6 volts while you're spinning the engine for 15 seconds, I don't do that more than once because you'll begin to heat the starter up. But if your starter's, nice and cool, it hasn't been overworked and all that kind of thing, you spin it 15 seconds, if it stays above 9.6 volts, that battery is sufficient for that car, which means that if it's a 4-cylinder, it's going to take less to spin it over than a 6 or an 8. See, there used to be an old rule of thumb that you wanted one cold cranking amp per cubic inch. That's ages ago, though. All right, this was my wheat harvest experience that I did. These are the combines. I drove one of those combines whenever we went on wheat harvest from Texas to Canada back in the mid-70s. I got out of high school, and my mother knew these people that I was born out there in Texas anyway. And she said, why don't you go hire on with these people as custom harvesters and go up the country? And so I did, and I went up the country. But as it was in so many other places I went, whenever they found out I could do mechanic work, they typically gave me things to do. That's just what they did. And we basically had a lot of work to do. That I had to rebuild the engine in a couple of these grain trucks, and that was me and the boss man and his brother out there in front of one of them internationals. And in Montana, that was the worst mosquitoes I'd ever seen. When we had to lift the front off those old bat wing doors on those older international trucks, we had to take the front off the truck to get the engine out of it. And we were putting the front back on. It was after we got the engine in there and bolted up and all. And when we put that front back on there, it was getting close to dark, and there were so many mosquitoes that got on my arm while I was carrying that hood over there that it looked like thick black hair on my arm. When I got through, I wiped my arm, and it was a bloody mess. But I've worked down in swamp country down there, and in the southeast Texas area, in Louisiana and around there. I've never seen mosquitoes as bad even down there as I saw in Montana out there, and it was just amazing to me. There was enough surface water out there for mosquitoes to breed the way those did. Also, when you were walking across the yard, there were huge crowds of grasshoppers flying away in front of you when you'd walk over. It's really amazing thing. Now this right here, I was banging on this, and this was kind of dumb because I should have known better. That's a wrist pin from a diesel piston, and that was something we used with the press. Okay, and so we used it for the press for years and years and years. And one day we were doing a bearing replacement on a car, and I decided to take this thing and beat on it. Well, I hit it a few times. And this little chunk that you see right here came shooting off of that and went into my leg. That's an x-ray of it. It's actually in that leg of mine, and it's about that far from the femoral artery. It stopped about an inch from there. And I basically, I hit it and I felt something, but I didn't immediately see any blood, but it went through my pants and into my leg. And then there was this big puddle of blood. It was rolling by my boot. My students called it my attention. I went in there and took my trousers down. And I got one of the students, the oldest one of them was a guy that was about 32 years old, but he was all nervous and everything. And I went in there and I said, bring me 2 of those gauze pads out of the first aid cabinet and a shop rag and that roll of masking tape out there, big 2-inch wide blue masking tape. And I made myself a compress to stop that thing from bleeding because it was pouring out of my leg about like the size of a drinking straw. And so basically I got it all wrapped up, and I went. And I had somebody from the college drive me to the emergency room over there, and they didn't want to cut that thing off because they didn't have a vascular surgeon. So I got, 30-mile ambulance ride. And when I got over there to the other hospital, the guy cut it off, and he said it basically clipped a bunch of little tributaries to that femoral vein in there, and that's where it didn't actually hit the artery, but it stopped just short of the artery. And this was basically a life-ending thing. When you injure yourself like that and you're doing a lot of bleeding, the smartest thing you can do is think clearly and slow down and just calm down. And that's basically what I did. But he left it in there because he told me, he said, I could go in there looking for that thing. But he said, I'd have to make an incision about 4 or 5 inches long and about 2 or 3 inches deep, and it would take you a long time to get over that. So what we're going to do is we're going to leave that thing in there, and it will spin a little cocoon around itself, and it will not have a, it won't, there's no chance really that it's going to move. The biggest problem is I can't have an MRI because that's a piece of steel, and MRI will jerk it out of there and there's no telling which way it may go. So I have to have a little medical alert bracelet that says I can't have an MRI because I got a piece of steel in my leg. Anyway, words to the wise, be very careful about it. I was wearing safety glasses, and basically if you're going to be doing something like that, you're supposed to be wearing a heavy canvas apron or something, but who does that when you're working in an automotive shop, Anyway, these 4.6 liter spark plugs, for some strange reason, and I have never dug into this, these things will sometimes screw themselves out and then they'll blow out of there. But right before they screw themselves completely out, they'll bounce a little bit in the threads and they'll mess up the threads, and then whenever you're trying to put a spark plug back in there that has blown out of there and destroyed the coil, then you'll basically have to fix the threads before you. I had to do it on my dad's Grand Marquis. It blew one of the plugs out, and I had to go in there. And usually, whenever I'm tapping out spark plug hole, I will take, if I'm in the shop where I got my air compressor, I'll take air blowing in through the throttle body, blow air through the throttle body and bar the engine over until there's air blowing out that spark plug hole, so that whenever you're tapping those threads, all of the little filings that are, or the little, cuttings that are coming off from cutting those threads will come blowing back out of the hole and won't fall in the cylinder. Well, on my dad's vehicle, it was in the parking lot of his apartment, and I had to get a bunch of grease, and that works too. You can put a bunch of grease on your tap, and it will basically, when you're tapping it down in there, you pull it out periodically and wipe that grease off, because that grease captures those filings and keeps them from getting in the cylinder. You don't just let them fall in the cylinder because that'll make a mess. But anyway, there's a friend of mine online that owns a shop, and he took every one of these spark plugs out, and they were, I guess, the original ones or some that had been in there a long time. Every one of them he was able to screw them out with his fingers. He didn't even need a ratchet to break them loose. But for some reason, those things like to screw themselves out of there and blow out of that hole. And it's really, I had run into that on a van that had a 6.8 liter V10 in it that we had at the college over there, and that was a humdinger right there. But this here was a Waukesha engine that I got my dad. You can see my dad back there running his sawmill. And this was back in the late 80s, whenever that, well actually it's in 96, I'm sorry, if you look at the date on it. He actually put it in the early 80s, but he ran it for about 15 years or more. But the long and short of it is that Waukesha engine, he had everything else he needed to run a sawmill, but I had that, well, I was working in Texas when he was originally putting in his sawmill, and I got this Waukesha engine for free because they took it out of service. That was where it was on a barge. They replaced it with a 671 Detroit. It was a 57 model Waukesha engine, and they even had the service manual with it and all that kind of stuff. And so it was pretty cool. I took that thing. It was skipping on one cylinder, and they didn't want to have to worry about fixing it because it was hard to get parts for it because the engine was so old even then. And my supervisor said I could have it if I wanted it. So I took a forklift, loaded it on my pickup, and took it back over there, and I got a Lease Neville starter for it from the local parts guy. He gave me one because he didn't like Lease Neville, he liked the Delco. Big old starter, like you'd put on a semi or something. And I actually had to design and build that power takeoff adapter complete with the clutch that was on the inside, so that he would be able to do it, because it came without a power takeoff. It came with no starter, so I had to put a starter and a power takeoff on it. And my dad, got it running. We had to build a push rod. One of the push rods was broke, so we had to build a push rod out of a piece of ball thread and actually put the little socket on the top of that piece of ball thread that was originally on the push rod, and we adjusted the valve and all that kind of stuff. Anyway, that engine, my dad could saw all day long with that engine. A sawmill really loads an engine heavy, but that engine would saw all day long on 10 gallons of fuel, which was really, really efficient. That was a fine diesel engine. It was a Waukesha, but I had never shown that picture on here before. Now, one day, there was this guy that pulled in the dealership, and he says, every now and then my Explorer just labor knocks to beat the band and just sounds like it's going to tear itself all to pieces, and I can switch it off and restart it, and it won't do that. And he says, and it'll be okay for a little while, and then it'll start doing it again. And he says, it just labor knocks to beat the band, and he said, it's just scary as all get out when it does that, because I just know it's going to tear itself apart. And so I said, well, let's just have a look at this. And so I took the breather, the top of the breather off, and laying on top of the air filter, which the air comes in from the bottom of the air filter, goes on top of the air filter. Somehow, when the air filter was changed, there was a half of a roach's wing that was lying in there on top of the air filter. And I figured what must have been going on was when he cranked it up periodically, it would fly up here and it would land right there on that screen and be held against that screen, and it was diverting the air that was supposed to be going through there past that mass airflow hot wire set. And so that thing right there, that would make it run lean because it would report less air, than what actually was there, because the air was coming through here, but it would be in red right here. And when that roach's wing popped up and got in front of it, like right there, it would block that. And so what I did was, I says, look, I'm not charging you anything for looking at this. Let's just go ahead and get this roach's wing out of here and just see what that does for you. And he never had that problem again. It was a very, very simple fix. Move the roach's wing out of the air filter area where it was laying on top of the air filter so that there was nothing to jump up here and partially clog that up. That's the Explorer's for you. All right, this right here is a torsion bar. Now, the reason that most vehicles that have torsion bars use torsion bars is because they'll be four-wheel drive, and because of the fact that the spring that ordinarily is on a vehicle without four-wheel drive is in the way, so that you can't have these axles going out there. They will actually have this torsion bar, and this is a sort of a shaped like a wrench, and the end of the torsion bar is shaped like a bolt. And then on the back, you got a little, these little it's got wrench shapes back there too. But you can actually adjust the tension of that torsion bar with an impact wrench. Changing the tension on the back of that bar. Pretty handy to be able to do that. But the thing about the torsion bars, and something you can find out accidentally, is that if you take those torsion bars off, you better have them marked, so that you have them marked left and right and front and rear, because if you put them back on there wrong, and you can do that, you're going to have suspension that's really tight and screwed up, because these things are made to twist a certain way. That's why on the end of these Chevy ones that you see right here, they've got them marked left and right. See what I'm saying? 963 and 964, those are the two different ones. If you just had laid those torsion bars on the floor without paying any attention to this, or without marking them, I like to get a piece of, just in spite of everything else, I like to get a piece of masking tape and put on the end of them, and I'll say right rear, left rear, so that when the torsion bars are put back in there, and a lot of times you have to pull them off to pull the transmission out, you put those torsion bars back in there exactly the way they came out, and watch your ride height when you're doing that. It's really a good idea to check your ride height. We talked about this the other day by measuring from the bottom of the rim to the fender on both sides in the front, and then what you're going to do is you're going to use your impact wrench up under there where you're adjusting where that torsion bar goes into the back. There's that little thing, it looks almost like a big fat wrench, because it fits right on the back of that torsion bar. And this bolt's actually going through against the pieces in that frame. But the point is, you can look under a vehicle with torsion bars, or a truck or something, you can see what I'm talking about. You can loosen or tighten that, and that changes the twist, the amount that those torsion bars twist. It's amazing to me that for a life of a vehicle, they can last twisting and twisting and twisting without popping. They probably do break sometimes. But that's really important stuff right there. And once again, you measure from the bottom of the rim to the fender. That's how you're going to get an accurate measurement. And you compare one side to the other, and then you tighten or loosen that bolt so that it changes, and you remeasure and make your adjustments accordingly. That's just a little thing right there. Then right here, there was a 93 Jeep Wrangler I worked on that came in there, and it was blowing this mist of gasoline out the tailpipe. And so I put the fuel pressure gauge on it, and I noticed that whenever you pressured it up, it would leak down really quickly. And I put the scope on it, and I noticed an anomaly there on one of the cylinders. So I went ahead and pulled the injectors out, the fuel rail out, and I found that injector right there, one of them, was just shooting fuel straight through it. Now every now and then, if you've got one that's shooting fuel straight through it, you need to unplug the wire to make sure that it's not got a shorted trigger wire somewhere that's triggering it to run fuel straight through. And of course, a lot of times you'll get a code in a situation like that. If this one here was mechanically stuck open, but there was nothing electrically wrong with it, and so we replaced the injector and took care of that problem. All right, what's being done here? Anybody that has ever done a smoke test on a leaking intake manifold can tell you just how valuable this is. The smoke test originally started coming around. I was laughing with my buddy one time, and I says, you know, there was a time when we used to use mirrors, you know, to find things, and now we use smoke in mirrors, which makes us sound like magicians and all. But if you take a bright light there and you've got an intake leak somewhere, you put pumps, you got to pump smoke into that intake and watch where the smoke comes out around the intake. Now you got to realize that you got to be discretionary about where the smoke's coming from. You got to know where the smoke's coming from so you'll know where your leak is, because where the smoke's coming out is where the air is going in. And just about every time I've ever checked one that had an EGR valve on it, there was a little bit of smoke that was coming out through and around the EGR valve, so don't let that bother you too much. That's not typically going to be where your problem is, but you can just about always find an EGR valve leaking smoke if you pump one full of smoke and all. Here's a question. The engine exhibits hard starting symptoms only when hot. What would be the most likely suspect area? Oil pressure, DTCs, fuel pressure, or spark? All right. What does one high firing spike usually mean when analyzing an ignition oscilloscope pattern? One high firing spike. A fallow spark plug, high secondary resistance on one plug circuit. One firing spike is always high, which would mean there's nothing wrong if you believe that. And there is a bad injector. So talk a little bit more about that in a minute. Which of the parts shown here are most likely to cause major engine damage? Throttle position sensor, catalytic converter, fuel pump, fuel pressure regulator. Question 4. Joe and his girlfriend are at the Burger Barn on her 2005 Ford, and he wants to impress her. Okay, he's behind the wheel. The engine spins normally but won't start. Joe gets out and pretends to do something under the hood. Although he does nothing, he just makes it look like he's doing something. And then the car starts fine, and she is very impressed. What do you think Joe did to make this happen? A stall test is performed on a 2000 Ford Expedition that produces a stall reading of 1800 RPM. The shop manual spec is 2800 RPM. What does this mean? ABS malfunction, loose engine mounts, torque converter issue, or high fuel pressure? Question 6. This is a TCC solenoid, VAPS solenoid, ICP sensor, or IPR solenoid. Question 7. Name one or more vehicle or engine related closed loop systems other than the O2 fuel trim system. Which connectors should be checked first when tracing a circuit? A, those closest to the load, B, those closest to the ground point, C, those closest to the power feed, or D, those most easily accessible. Question 9. Individual switches on automobile power window circuits must be connected, I meant to say must be connected blank with the driver's master switch, parallel in series, discretely, or with twisted pairs. A 2002 Crown Victoria's wiper blade doesn't clear the water on the driver's side. In other words, it doesn't wipe the way it should. The wiper blade has been changed 4 times with 4 different brands, but it still has the same problem. What should be done next? All right, here's the answers to the 10 questions. An engine exhibits a hard start and symptoms only when hot. The most likely suspect is going to be fuel pressure. If that fuel pressure doesn't hold whenever you shut it off, that fuel pressure ought to hold very steady for quite a little while. You know, we used to find, we shut it off, and if it's leaking down, if it leaks down and it's not holding pressure in there, that fuel's going to make bubbles in there. It's actually going to expand. You're going to have foam in there, and for a little bit when you're trying to start it, it's going to wind up squirting out foam instead of fuel until it gets rid of all that air that's trapped in the fuel rail. All right. What does one high firing spike usually mean? This right here, you'll usually have a secondary resistance high. However, this is crazy, the one that I worked on, the Jeep Wrangler I was talking about, this is the scope pattern from that. And that firing pattern was really high on the one that had the leaking injector. and that gasoline spraying in there, you'd think that would cause it to have a lower one because it would foul the plug, but it actually was really high like that, which was very peculiar. All right, which of the parts shown is most likely to cause major injury? If the diaphragm ruptures in this, and enough fuel goes out of that vacuum port and goes into the intake manifold, and you're going to have, you can actually have it going into the cylinders and hydraulic locking them. I have actually seen this happen on more than one occasion. And it doesn't always cause major engine damage, but it can. If enough gasoline gets in the oil, it can damage it that way. If enough of this hydraulic locks on the piston and somebody spins it over and that piston comes up with enough force to bend it, you know, you got issues there. So that's the one that's the most likely to cause major engine damage. Now, on some of your Nissan Altimas and some of the old SHO Tauruses, if the catalytic converter, the brick starts to break up, it can pick up chunks of that rock, of that clay that the catalytic converter is made of, and it can funnel it back through the EGR system into the engine and destroy the engine that way. That has happened. It's fairly common on some of the early 2000s Altimas, and we've had to replace some engines because of that. If you've got an Altima that's making a bunch of engine noise and you just pop an engine in it without getting your borescope, looking down through that O2 hole into that catalytic converter, you're liable to have one record-breaking comeback on one of those. So typically, if you're replacing a noisy engine on an Altima and you can't figure out what went wrong, you'll see, and I've got pictures somewhere of that were on some we did. You'll see that catalytic converter came apart, and that's something that does happen on those Nissan Altimas. And this, Joe put it in clear flood mode by pressing the accelerator to the floor while spinning the engine. It won't do this on every single vehicle you do it on. Some of them don't have a clear flow, but most of them do. But if there's any fuel puddled up in the intake manifold and you do this, you have to be ready to jerk your foot off the gas really fast if it tries to start, because if you got your foot on the floor and you got slow reflexes, you're liable to tack the engine out and you could cause a problem. But whenever I was working with my students over there, like there was a 2005 Ford Freestar, I think it was, whatever it was. Anyway, we would actually, when I would show them, this is clear flood mode. Clear flood mode is letting air pump through there and dry the spark plugs out in case it was flooded for whatever reason. And so anyway, you could actually do that. And I told my nephew, and I showed him that. I said, if you want to impress some girl, he was still single then, I says, just, you know, get in there and act like, you know, oh yeah, I know what's wrong with this. You get out and act like you're doing something. They're going to be really impressed every time because it makes you look like super mechanic, even though you may not have known anything except that clear flood mode keeps it from starting when you push the gas pedal all the way to the floor. A stall test performed on a 2000 Ford Expedition produces a stall reading of 1800 RPM. That's going to be a torque converter issue. Now the caveat is if the engine is underpowered for some reason, like if the catalytic converter is stopped up and the engine can't breathe, you're going to have a low stall speed. But that's almost like a dynamometer. What you can do, what you got to do is you got to hold the foot brake really hard, lock the park brake while you're holding the foot brake. It gives you that much more braking pressure. And then you put it down and drive. Make sure whatever you put it in is not going to, there's nothing in the, you know, like if you got wide open spaces behind you and there's a building in front of you, I like to do this in reverse. So if it does try to get away, it won't, you know, I can stop it before it causes damage. Anyway, hold your gas pedal all the way to the floor and see when the tach stops gaining RPM. That's your stall speed. And that's how you check the torque converter. If the one-way clutch, the stator in the center of the torque converter between the impeller and the turbine is actually got a one-way clutch, and if that one-way clutch is letting that stator spin both ways, you won't get torque multiplication, and you'll actually wind up with a lower stall speed. I've actually run into that on a nearly brand new Expedition that belonged to my shop foreman, and we were looking for an engine skip, trying to load the engine while the, you know, to see if which coil would drop out, and we discovered that, I think it was 2900 was what his listed stall speed was supposed to be. Sometimes it's difficult to find that stall speed specification in the book, but most all transmissions have an acceptable stall speed. Of course, you know, there's a lot of transmissions you don't need to do that on any and every transmission. I would say to look up the stall speed. If you can find a stall speed spec in the book, then that means that you can actually do a stall speed test safely. I could talk more about that, but I'm going to move on. This is a IPR solenoid from a 7.3, and you see how this is made right here? that actually fits really, really close to that passage that it goes through. This is called an edge filter. Vacuum cleaners do this. You'll see vacuum cleaners that'll have a similar designed plastic shell in there, and they're really, really close to the side of the chamber around them, so that nothing can get past that, or very little of anything can get past the distance between this and that. So people they used to ask when we were working on the Power Strokes, they said, do they have an edge filter? We wondered what in a sand mill that was. Edge filter meant that the edge of it was cut so that it was very, very close, so that anything that went past there would stop just because there was not enough room. The fluid would go by, but any solid material would stop right there. I should have drawn a diagram, but that's an IPR solenoid. You get a code 1211 or something like that, that's usually what's going on. That thing's kind of aggravating to change if you hadn't done it before. That is a 1 1/8 is what side wrench fits that, by the way. But you got to screw that little nut off, that little stamped steel nut, and then you got to slide that little spacer off, then you got to slide the solenoid off, and then this winds up being a stem that is sticking out on that end, and that's what the IPR solenoid is. It controls the oil control pressure for the injectors on the Huey systems. Name one or more vehicles that are engine-related systems other than the O2 fuel. In other words, you want to closed-loop systems are all over the place on cars nowadays. Your climate control is a closed-loop system. Your thermostat in your house is a closed-loop system. That means that whatever is making the decisions on what to do can measure a particular outcome and change the input to change the outcome. That's what that's the most one. When you talk about closed loop, everybody thinks about O2 fuel trim. EGR system, it's going to do that too. It's basically looking at where the EGR valve is as to where, how much flow it's got. If it doesn't have enough, it opens a little more. If it's got too much, and you're got a closed loop system. When you turn on your radio, if you don't like the station it's on, you change it. If you like it, if it's too loud, you turn it down. If it's too much bass, you dial in a little more treble. That's a closed loop system with your ear and your hands being think of some other. Closed loop goes a lot deeper than that. Which connector should be checked first when tracing a circuit? The easiest ones to get to. I've talked about this in another one of these tests. Individual switches on automotive power windows got to be connected in series. They're connected in series. For that reason, let's say I've got in vehicles and I was working on a lot of power windows and stuff when I was doing a lot of electrical work, and let's say my passenger side power window doesn't work, but my driver's side power window and the passenger side window will work from the power window switch on the driver's side. In other words, the master switch would operate the passenger's window, but the passenger switch wouldn't operate the passenger's window, and the lock function wasn't there. Okay, so what I have found is you can change the master switch and still have the same problem. It can be either one of those switches. The master switch can keep that one, because the passenger side switch depends on ground feed. When the master switch is at rest, both of those wires are fed a ground, and you're basically just rocking one of them into power whenever you're operating that window. So you can have a bad switch on the master switch or a bad power window switch on the passenger side. Either one of those can keep that window from working. And that'd be true with the back windows too. But don't get falling in a trap like that. 92 Crown Victoria's wiper blade doesn't clear the water. Replace the wiper arm. I've run into this more than once or twice where people were saying, we've put wiper blades on this repeatedly in all different brands and it still won't clean. And my dad's Grand Marquis was like that. And you change that wiper arm, it's not hard to do. They typically keep them in stock. You can fool with that wiper arm and bend around on it and play with it. It looks just fine. The spring is good. But replacing that wiper arm is what it takes to get the wiper to clean in the windshield right. I've never been able to figure out why, but whenever there's nothing else left, that has to be what it is. That's your Occam's razor thing, right? Because if the wiper blade didn't fix it, then the arm must be something wrong with that wiper arm. And so having replacing the wiper arm, that thing must be tuned a particular way. But anyhow, I've actually fixed them like that. Well, I hope you had a good time with this one. And have you a cup of coffee and enjoy your day. And I'll talk to you later.